All right, so we've talked through how to reverse a linked list iteratively. Now let's think about how to do it recursively. And so it's a bit tricky to think through like how this should start. But here's a useful way to think about it. So what does reverse list do? Reverse list, you give it the head of a linked list, and then it reverses the list and returns the head of the new list. So it returns something and it does something. What it does is it reverses all the arrows, so it reverses the linked list, and then what it returns is the head of that reverse list. Okay, and so if we were to think about how we would, if reverse list, if this were an iterative function, how would it work? And so basically, So if we're thinking about this iteratively, there's sort of like two ways that it could be iterative. I'm just going to do this. Let's just say we have some sort of linked list here. It doesn't matter what the values are, so I'm not even going to fill them in. But if we have a if we have a linked list, if this were to be recursive in some fashion, it would need to go in some direction through the original linked list. And so it turns out the way that makes the way that's the most useful for actually like solving this is the way that we could think about it is we have this function reverse list that reverses a linked list and returns the head of a linked list. If this function only worked up to a particular node, could we make it work one node further? And so there's sort of two directions that you could ask this question is if you if it could work for all the nodes up to n, then could it work for the next node after n? Or the other direction would be if it could work on all nodes after n, could it work for node n as well? And it turns out the second approach is the most useful for actually solving this. Okay, so let's say we have, and whatever the values are, let's just say that this is node n. It doesn't matter what the value of the node is, but let's just say if we were to like number all of the nodes, this would be the nth node. Okay. So if we had, let's see, I'll use reversed RL to revert to reverse list, the function. And what this function does, remember, is it reverses, if you give it a node, it will take the linked list starting at that node, reverse it, and return the head of that reversed list. Okay. So now, suppose that this function worked on nodes, all nodes after n. So let's suppose it worked for nodes n plus 1, n plus 2, all the way through the remainder of the linked list. Could we write this function so that it could also work for node n. Okay, so if we think about this, we have this function reverse list, and we give it a head of some reverse list. And let's suppose that we could get some, let's suppose that we could call this function on all nodes after this particular head. Here the head is node n. I'm actually just going to write, no, we'll keep it like this. Let's say that this function would work if head is any node that comes after node n in this original linked list. Okay, so what could we do here to use such a function to reverse the linked list up to, for all nodes after and including node n, not just after and including n plus 1? Well, we certainly know that we could, let's say that this is node n plus 1. We could reverse everything after n plus 1. Okay, so what would this be? We would get the reversed head equals RL of node n plus 1. So here, with how we're writing this function, this would be head.next, because that's the next thing that comes after node n. Okay. So if we were to call this function, then what would happen in this diagram that we have here? If this were the linked list that we were working with, and node n were the head that we were plugging into this function, and then we were to do, we were to call RL on head.next. We're assuming that that RL is able to do this. Then what it would do is it would reverse everything after, everything starting at the node head.next, and return the head of that reverse list. Okay, so what would it look like if we reversed everything here? So this final node would no longer be pointing to none. It would instead be pointing to the node that comes before it. And then this node would be pointing to none because it would be the end of the linked list. Okay, and then reversed head would refer to the head of this reversed list. So reversed, I'm just going to say RH. No, I should write it out. So this is reversed head. Just to be clear that it's referring to this node here, and it's not at all related to none over here. Okay. So if we're in this scenario, can we now reverse everything up to and including the head? Okay, well, what would we need to do? We would basically, all we would need to do is we would need to reverse this arrow so that node n plus 1, instead of pointing to none, would be pointing to node n. And then node n would just be pointing to none. That's really all we need to do. Okay, so what are those two steps here? So node n plus 1 needs to be referring to node n. So how do we refer to these nodes? So node n plus 1, this is the node that comes after head. So, and we need to update the thing that node n plus 1 points to. So we're going to need to update node n plus 1 dot next. And node n+1 itself is head.next. So what we're going to update is head.next.next. Because remember, head.next.next is what node n+1 points to. And it needs to point to what is currently the head. So we're simply going to have head.next.next point to head. And so that will update this arrow to point here. And then head needs to point to none. So head.next will now be none. Oh, and after we reverse this arrow, that goes away immediately because this can only point to one thing and we updated it to point to head. Okay. All right, and then remember this function needs to return the head of the reversed list. Well, now that we've done this, the head hasn't changed at all. This reversed head is still the head of the reversed list up to and including node n+1 is the same as the head of the reversed list. No, the head of the reversed list after reversing nodes n+1 and beyond is the same as the head of the reversed list after reversing nodes n and beyond. And so the head, or what we need to return here, is the head of the reversed list, which is still the same reversed head. So we're going to return reversed head. Okay. And so indeed, this code is sufficient for assuming that this line works here, assuming that we're able to call reverse list on head.next and have it do everything that we need it to do. Meaning, as long as it is able to reverse the list starting at head.next and return the head of that reversed list, then we can also reverse the list starting at node n, or starting at the head, and return the head of that reversed list. And so this takes care of the inductive step for this recursive function. What else do we need to take care of? We need to take care of the base case. So what would be the base case? So if we just, let's go back to the, original, maybe not the original here. Let's say we have some linked list here. If we feed in none, then it should just return none because there's no list to reverse. If we feed it just the final node in the list, then it needs to be updated so that this is the node that is returned, and it points to none. Okay. So, but that's already done. And so we don't actually need to update anything. And so basically in the base case, we just need to return the head. So if not head or not head.next, then we return the head. Okay. So again, just to review like what these two scenarios are. Not head refers to the scenario where the head is null, or the head is none, meaning that there is no reverse list. And so there's no arrows that need to be adjusted, and you just return that head. There's no arrows to be adjusted because there's no nodes at all to adjust in the first place. Not head.next refers to this scenario where the node that's given is the final node in the linked list. And in this scenario, there's only a single node and it already points, there's only a single node, which is head, and it already points to none. And so we just need to return that node and not update any arrows. And so that's why this works. Okay, so now this code works in both the base case and the in the inductive step. It works as well. And the only thing that we need to verify is, does this work at the very end? Well, we've just said that by the inductive hypothesis, if you give it, this function is such that if you give it a node, then it will reverse the list starting at that node and return the head of the reversed list. And if it works at node n plus 1, then it will work at node n. And so it can work as at any node that you call to it. And so if you call it on the first node, if you call it on the head of the original linked list, then it will reverse all nodes starting at that node, meaning that it reverses the entire list. And then it returns the head of that reverse list, which is exactly what we are looking to return. And so this function, you can indeed plug in the head of the linked list, and it will return exactly what you need. Okay, so that is how this works. And so now we just need to write it out. Now the thing here is that LeetCode doesn't let you work with this recursively, so we need to make our own recursive function. So reverse list recursive, and we're going to give it a head. If the head is null, or head is none, or head.next is none, then we're just going to return the head and we don't need to do anything else. Otherwise, we're going to reverse everything after the head and get the head of that reversed list. And then we're going to include the current head in that reversed list, meaning that head.next.next is updated to be head, which is just reversing that arrow. And then the head needs to point to none. And now we return the reversed head because the head of the reversed list hasn't changed. Okay. And then all we need to do is call this on the head that is provided in the original function, right? So we can test this. And it is wrong. I made a mistake. It returns nothing. If I'm doing a recursive function, I should probably have some recursion in here. Why did I think to put reversed head is head.next? I don't know. But this is completely false and not useful. This is where we actually do the recursion. Oh, duh. That's why I did it, because I just put the input to the recursive function and I didn't actually input it into the recursive function. Okay. All right. So now this should actually work. And it doesn't. Okay. Okay. Yes, this is the thing that we want to output, so we should probably return it. There we go. All right. submit this, and there we go. Okay, cool. So, yeah, this is how to do this using recursion. And yeah, it is definitely tricky to think through this, but you know, this is just how you do it. So that is the solution to this exercise. And so now we have solved this both iteratively and recursively.